We saw how the pressure is going to change in a liquid, and we also saw the Pascal's law, correct? Now, there was a very big question which was, posing to the scientists that what if instead of a cylindrical container, what if I change the shape of the container, and fill it with liquid? Will the pressure change at the bottom? Like, instead of a cylinder, what if I have a conical shaped, maybe a beaker, or what if I have a spherical shaped beaker? What if you have different, like, irregular shaped beakers? Will the pressure be the same at the bottom of those beakers? This was one of the questions. Understood? Now, to understand this one, look at this particular figure. Now, what you have three different shapes, correct? But one thing what you have to notice here is that the level of the liquid is the same, correct? In all the three containers, the level of liquid is the same. Now, when they checked the pressure at the bottom of these three beakers, what they understood was the pressure was the same. All right. Now, they called it as hydrostatic paradox. The reason why they called it as paradox because now, if you look at first and the second figure, because the amount of water is not the same, correct? What is same is the height, but the amount of liquid is changing, correct? Even though the amount of liquid is changing, the pressure is constant, isn't it? Then they came to the conclusion that the shape of the container has nothing to do with the pressure or pressure at the bottom of this particular beaker experiment, whatever we are doing, the pressure is independent of the shape of the container, but only depends on the depth or the height of this particular liquid column. All right. Now, this is what we call as hydrostatic paradox. Now, we make use of this in a lot of practical applications. Okay. Now, where we are going to use it? Now, to understand about atmospheric pressure, we make use of this experiment, or we make use of this one. Okay. Like you don't need to have a cylindrical column all the time. You can have any shape. Any shape will work. All right. Now, this hydrostatic paradox has a lot of advantages also. But the main point of hydrostatic paradox is that it reinforces the fact that pressure depends only on the depth or the height and is independent of the shape of the container. All right. This is the whole point of hydrostatic paradox, what you just learned.